Your next question is 10th question C part. Explain the construction, working and characteristics of N-channel depletion type MOSFET. It is asked for 10 marks from January, February 2021. Okay. So first let us start with your construction of your, it is N-channel depletion type MOSFET, metal oxide semiconductor field effect transistor. Okay. So before the construction, let me draw the symbol. So what will be your symbol of your N-channel Jfet? So you will be having, what is the difference between your sorry, it is not Jfet, it is MOSFET, right? So difference between Jfet and MOSFET, the difference lies in the symbol, right? So this will be your gate terminal, and here you are going to have your drain terminal. You have a substrate, so N channel, so you have an arrow mark pointing towards, and your substrate, this is your substrate SS, which is connected to your source terminal. So this is your symbol of your N-channel depletion type MOSFET. So what will be your construction? Your construction will be, you'll be having a P-type substrate, right? P-type substrate. So this is taken as your SS substrate, to which your two heavily doped N-type semiconductor is connected, which will have a channel. So physically a channel is being present. So this will be your channel. Okay. Now two metal contacts will be taken from this N-type semiconductor, and this layer is called as your silicon dioxide layer. It is an insulator, right? Silicon dioxide layer. And so two metal contact will be taken from the N-type semiconductor, which will act as a terminal. One is your source and the other will be your drain. Now the gate is connected directly to your silicon dioxide layer. There is no electrical connection between your channel and your gate. Okay. So this will be your construction principle, and the source will be connected to your substrate. Okay. Now this is your construction of your N-type depletion type MOSFET. What is asked in the next question, that is working. Okay. Now let us move on to the working principle of your N-type depletion MOSFET. So working, mainly your depletion type MOSFET works in three cases. Okay. So what is your first case? When VGS is equal to 0 and you are going to apply VDS positive. That is your first condition. Second condition is when VGS is equal to negative and again VDS is equal to positive, and VGS is equal to, third condition, when VGS is equal to positive and VDS is equal to positive. Okay. So mainly your gate to source voltage will control the characteristics curve or your current flow, output current flow. So your, when VGS is equal to 0 and when VGS is equal to minus, that is your negative, it is called as your depletion mode. It works in two modes. Okay. One is your depletion mode, and the third is called as third condition, that is when VGS is equal to positive, it is called as your enhancement mode. So it works in two modes. One is your depletion mode and the other one is your enhancement mode. Now let us go on for your first case, when VGS is equal to 0 and when VDS is equal to positive. Let me draw with your symbol. Okay. So this will be your drain. This will be your substrate which is connected to your source. Now when VGS is equal to 0, that is VGS, this is your gate, right? So VGS is equal to 0, it is shorted and you are going to apply a small positive voltage. Source will be grounded. So this will be your VDS. Okay. So when I apply VDS here, okay, when your drain and the source is connected, when I apply a positive potential here, what will happen? The electrons from the source will be flowing towards your positive potential of your drain. Right. So what will happen? The flow of the electron starts to flow from your source to drain. When electron starts to flow from your source to drain, equal and opposite, what will be generated? Current will be generated. So the ID flows in the opposite direction, that is from drain to source. So this will be your current ID. Okay. From drain to source. So you will be having a drain current flowing. After some time you will be having a depletion layer also. After a certain instant of time you will be having the current to be saturated. Once this channel is full with your electrons, your current will get saturated. So that I will be explaining you with the characteristic graph. Okay. So this is your first condition. So when VGS is equal to 0, when VDS is equal to positive, what will happen? The electrons will get attracted towards your drain's positive potential, and you will be having current to be flowing in the opposite direction from the drain to the source. Okay. Now let us consider the second case. Now second case, when VGS is equal to negative, what will happen? When VDS is again positive. Now in addition to positive potential of your VDS, you are going to apply, this is your first condition or first case. Now second condition, you are going to apply your negative potential. Okay, so this will be your drain, substrate, source. This is going to be the same as that of your previous. Source will be grounded. Now you are going to apply negative potential. So when you have a negative potential across your gate, what will happen? Now I am applying here negative. So your capacitor, it acts as a capacitor, right? Because there is no direct electrical connection between your gate and the source. So this is an insulator. It acts as a capacitor. Now when I apply the negative potential here, the electron starts accumulating towards your gate due to the negative potential. If I apply here, for example, so this will be your circuit, negative potential, and drain will be connected positive. Okay. So this is your second condition. So due to this negative potential, electrons will be towards your gate side, and when you have your electrons in your gate side, what will happen? Equal and opposite, what is a property of your capacitor? Equal and opposite charges will be accumulated, right? So here your p-type substrate, the majority carriers is your holes, right? So what this negative charge carriers will do? It will attract the holes towards your, because here it is negative, it will be attracting the holes towards your channel from the p-type substrate. Slowly the hole starts accumulating here. When you have the holes starting to accumulate here, the number of electrons will be reduced, right? This is an n channel. So when you have the number of electrons to be reduced, what will happen? The drain current decreases. So this is very, very important. When VGS is equal to negative, the drain current starts decreasing. Okay. So that is the specialty of when VGS is equal to negative. ID starts decreasing. As you increase your negative potential, equal and opposite positive holes will be accumulated. When it completely fills with the holes, there will be no current. ID current will be equal to 0 at pinch of voltage. That is as your VGS keeps on increasing in the negative potential. Okay, that is your second case. Now what is happening in your third case? When VGS is equal to positive. Now this is your second case. Now if I give here, when VGS is equal to positive, the opposite happens. Now holes will be accumulated. For the third case, holes will be accumulated here. When you have the holes accumulated here, the capacitor, what will happen? It will again further, it will attract the electrons. Here there is minority carriers as electrons, right? Those minority carriers electrons also will be attracted to the already existing electrons. So what will happen? There will be a huge increase in the amount of the electrons, and your ID current increases very rapidly. Okay, so that is why it is called as your enhanced mode or enhancement mode. Okay, which will increase your ID current, enhance the current, ID current. Okay, ID current increases. So this is your specialty of your enhancement mode. So let me draw the diagram of your third. So this will be your gate, drain, substrate, source. Okay, here you will be having positive potential. Source will be grounded. Here in this case it will be positive, negative. So this is your enhancement mode. So these two are depletion, this is your enhancement. Now moving on to the characteristics. What will be your characteristics curve? You have two characteristic curve. Okay, one is called as your output characteristics or drain characteristics, and the second one is called as your, or it is output characteristics, and the second one is called as your transfer characteristics. So transfer characteristics or your input characteristics. So what is your drain characteristics or your output characteristics? When you draw the graph keeping varying your output parameters. So what is your output current parameters? One is your current and your voltage. Output current is your current ID, and your output voltage your current VDS, keeping what as constant? VGS as constant. So first you will be having VGS, right? This will be your VGS is equal to 0, and it works in two conditions. When VGS is equal to negative, So when VGS is equal to minus 1 volt, VGS is equal to minus 2 volt, it keeps on increasing, more negative, it becomes more and more negative. Minus 3 volt, minus 4 volt, minus 5 volt, etc. So once it reaches as a pinch of voltage, your ID current becomes 0. So this is called as your depletion mode. Okay. And your next one is your enhancement mode, where your VGS, that is your current, will increase rapidly when VGS is equal to plus 1 volt, plus 2 volt, plus 3 volt, etc. So this will be your enhancement mode. Okay. So this is your drain characteristics. So moving on to your transfer characteristics. What is your transfer characteristic opposite to that of your drain characteristics? A graph which is plotted between your current ID and your input voltage is called as your transfer characteristics. Okay. So what will happen? It works in two modes, right? Depletion mode and enhancement mode. When you have VGS is equal to negative, the ID current starts decreasing, and once it reaches a pinch of voltage, that is pinch of VP, what will happen? Your ID current becomes 0. This is called as your depletion mode. Okay. So when VGS is equal to positive, what will happen? There will be a huge increase in your ID current. So this is called as your enhancement mode. So these are the different important points which you can write for your construction, working principle, and your characteristics of your N-type depletion type MOSFET.